route to Mars right now is the ExoMars 2016 mission, and the Open University has experiments on both the lander and the orbiter.
This is a real exciting time in Mars exploration, I think. We think we may have seen signs of life on Mars. So we're sending a dedicated instrument there to measure methane in unprecedented detail.
And we actually have a very poor understanding of the chemistry of the Martian atmosphere at the moment, so we really need to measure the gases that are there.
If all goes well, Schiaparelli, the lander, will touch down on October the 19th, Europe and Russia's first time on the Red Planet. But the very thin atmosphere will make for a challenging descent.
Schiaparelli is a Pathfinder mission in that sense to demonstrate the technology works and to learn more about how to land on Mars. My role is twofold in Schiaparelli. It's to predict the conditions it's likely to encounter as it flies through the atmosphere, and afterwards to analyse how much it has slowed down and see if we can learn something about the structure of the atmosphere from that.
There's two main instruments on the lander. One measures the entry profile as the lander goes through the atmosphere. My role on that is looking at the impact trace of the landing itself, so we can see when it landed, and we can see the kind of material it landed in by the force that goes through the lander when it lands. And then the other role is on the MET package, so there's a meteorology package, essentially a small weather station that we're sending to the surface. It will last for a couple of days, maybe longer, depends how long the batteries last.
And the most exciting science discovery may come from an instrument on the trace gas orbiter called NOMAD.
So at the Open University we have built one of the three spectrometers that is inside NOMAD. It's called UVIS, and it's a spectrometer that looks at visible and ultraviolet light. So the kind of light that we get on Earth, the kind of light we see with our eyes. By looking at the sunlight we can figure out the gases that are present in the atmosphere. The key thing we're looking for is obviously methane.
The orbiter in a few years' time will gradually build up a picture that might give us hints that there could be signs of life on Mars. It will confirm whether methane is really in the atmosphere. It will suggest where that methane is being released from and when it's being released. So we'll start to learn more about it and see whether that's consistent with the various ideas for how it could be produced. One of the reasons why we want to monitor gases in the Martian atmosphere is to try to pinpoint their sources and sinks. Are they being released generally, or are they being released from specific places? And perhaps those places would be exciting targets for future exploration.
The idea of building something, putting it on a rocket, sending it to Mars and getting data back from it, looking at things that no one else has looked for, it's immensely exciting, and it's the reason I do what I do. It's not a job, it's a real passion.
在雪里，在霜里，妈妈，你是否有懂？